Hi everyone, this is 10.2, Arithmetic Sequences and Series. So we're going to start with a definition of an arithmetic sequence. An arithmetic sequence is a sequence where each subsequent term, differs by a constant amount. So for example, here we go from 3 to 10 to 17. Well, 3 to 10 is plus 7, 10 to 17 is plus 7, and so forth. Right, that's our common difference, which is constant, is the same every time. The way we define that, we can find that common difference. We can find that common difference by subtracting any term from its preceding term. Right, 38 minus 31 is 7. 17 minus 10 is 7. That common difference is found by subtracting any term from its previous term. We actually have a formula that we are going to use throughout this lesson to find the nth term, the general term of an arithmetic sequence. The way we write this is we say a sub n, the nth term in a sequence, can be found by taking the first term, a sub 1, and adding to it the n minus 1 times d. So what we're really doing is we say, well, d is our common difference, the amount we add each time. And if we start at the first term, we are going to add 1 less than the term we are on. So if I wanted to find the 24th term, I'm going to take my first term and add my common difference 23 times, n minus 1 times. A little bit more vocab here. An arithmetic sequence is a linear function. If it feels like it is that easy, I agree. It is just a linear function whose domain is the set of positive numbers. The slope of the function is what we can consider the common difference, and which we call d, and the y-intercept is a sub 0, which equals the first term, a sub 1, minus d, if 0 were in the domain of the function. Now, we won't usually have a y-intercept on these because we define an arithmetic sequence, its domain as positive, so the y-intercept is more kind of theoretical and just to draw a connection to what we saw back in Algebra 1. So here we have an example. We have 2, 6, 10, 14, 18. We can see that our d value, our common difference, will be 4. Every term increases by 4. If I wanted to find the nth term in my sequence, I would take 2, my first term, and add to it 4, my common difference, times n minus 1. If I wanted to graph those points, I would still see at 1, 2, at 2, 6, (3, 10, 4, 14, right, and so forth. Something approximating a linear function. Now, we wouldn't want to connect these points. These values are just enough here to have those coordinate pairs. So let's look at some examples and how this looks. They might, number 1, they're asking us to write a formula for the nth term in an arithmetic sequence of 14, 11, 8, and so forth, and then find the 23rd term in this sequence. Well, I know that the general form is going to be a sub n, the first term plus n minus 1 times our common difference. Well, in this case, our first term is 14. We're still going to use n minus 1. And we're going to multiply that times our common difference, negative 3. So if I wanted to find the nth unit in my sequence, I would use the formula that you have there. Well, all I need to do, if I want to find the 23rd term, is I'm going to find a sub 23, the 23rd term in sequence. So 14 gets added to 23 minus 1, or 22 times negative 3. When we evaluate that, our 23rd term in this sequence will be negative 52. Now we can do the same, we are going to look at example 2 as well, where they ask us to find the 8th term of an arithmetic sequence whose first term is 4 and whose third term is negative 10. So there's a little bit of complexity here. We know that our general nth term in the sequence is going to be a sub n equals a sub 1, our first term, plus n minus 1 times d. So let's fill in what we know. Well, we know that the first term is 4. I'm still going to use n minus 1 because we're not necessarily looking for a specific value here. But if the first term, a sub 1 is 4 and a sub 3 is negative 10, I need to figure out the common difference. I need to basically take the average of these two values because the second term will be halfway between the first and the third. Well, negative 10 plus 4 over 2 gets us to negative 3. We can see now that our common difference will be negative 7. So that's what I can plug in here. They want us to find the 8th term in this sequence, so a sub n will equal 4 minus 7 times negative 7, or negative 45. Sorry, this should be plus. These arithmetic sequences are relatively straightforward and simple. They're arithmetic or linear, so there's not too much complexity here. One thing we can do with them is to create a series. A series is the sum of the elements in a sequence. We have some formulas here. We have one form. The sum of if I wanted to find the partial sum of an arithmetic sequence, in other words, the sum of the first n terms in a sequence, I can follow these instructions. I would take the sum of the first and the last term, which would be a1 plus an, and then multiply it times half the number of terms, n over 2. Or we can think about this as the same as n times the average of a1 plus an, as you see here. Either way, we end up with the same result. Form 2, we can use our sigma notation. We can say the sum from I equals 1 to n of a sub I. Looking at example 3 here, they ask us to find the sum of the first 100 positive integers. So what this really represents is 1 plus 2 plus 3, and so forth. Rather than going through that process, we can use our formula. We can say that we can take the number of terms, 100, divided by 2, times the sum of the first and last term in the sequence. This will be 50 times 101, or 5,050. The way to understand this kind of more intuitively is that this whole sequence, every pair of numbers, if we were to fold this whole sequence onto itself, would kind of map on to another. So the end of this sequence would be 98 plus 99 plus 100. Well, if I take the two outermost terms, 1 and 100, I get 101. 2 and 99, I get 101. 3 and 98, I get 101. That's what this quantity here represents. Each pair of numbers starting from the outside in has a sum of 101, and we have a total of 50 of those pairs. So there's 50 pairs, each of which have a sum of 101. We can multiply those quantities together to get the sum of the first 100 positive integers. We can also do this same process for an application problem. Here we have a steel ball dropped from a plane and with little air resistance during the fall. During the first second, we fall 4.9 meters. During the second, 14.7 meters. And in the third, 24.5 meters. During the fourth second, 34.3 meters. So this is, we should use A sub 1, A sub 2, A sub 3, and A sub 4. What they're asking us, what is A sub 5? How far does it fall in the fifth second? What is A sub 10? And what is the total displacement after 5 and 10 seconds? We'll talk more about that once we figure out our fifth and 10th term. What we have here is we have an arithmetic sequence. Every time the amount of distance we've increased goes up by 9.8 meters. That 9.8 is our common difference. If I wanted to find the fifth term in my sequence, all I need to do is add 9.8 to 34.31, and we would get 44.1 meters. While we have this sequence in front of us, it's easy to add on recursively, right? Add 9.8 to the previous one. But finding the 10th, I think we're better off using our formula. To find the 10th term in their sequence, we're going to take our first term, add to it the number of increases, n minus 1, or 10 minus 1 is 9, times our common difference of 9.8. We plug that into our calculator and evaluate, and we get the 10th term in our sequence, the distance that we fall, that this steel ball drops in the 10th second, is 93.1 meters. The second half of this problem asks about displacement. In other words, how far has this steel ball fallen after 5 seconds, after 10 seconds? So the displacement problem, let's use a different color here. For displacement, I'm really finding two things. I'm finding S of 5, the sum of the first 5, and S of 10, the sum of the first 10 numbers in sequence. S of 5 will be the number of terms divided by 2 times the first term, plus the last term, which we found to be 44.1. That's that same formula we just saw. S of 5 will equal 122.5 meters. What that means is that after 5 seconds, this steel ball has fallen a total of 122.5 meters. S of 10, same idea here. Instead of having 5 terms, we have 10. We still have the same first term in our sequence, but our last term in our sequence is now 93.1. Well, now we're going to evaluate S of 10 and find the total displacement to be 490 meters. Again, we are adding up the total distance that this steel ball has fallen combined in the first 5 or 10 seconds in each of these problems. We're going to look at one more problem together. I would say you should try this on your own. The remainder of these notes will be calculator based, and I'll post a separate video for those. So let's pause right here and try number 5. You're going to try to find the sum of the first 25 terms in the given series. Let's see what you can do. All right, so let's see how it went. So in this problem, I started here. I knew that I had to find the sum of the first 25 terms in a series. So I'm using that formula, n over 2 times a1 plus an. Well, I know that I have 25 terms, and I'm going to divide that by 2. But I don't know the 25th term in the series. So I had to go figure that out first. So I worked over here, figuring out the 25th term, right, using that formula from the beginning of our notes, 11 plus 3 times 24 is 83. That 83 gets plugged into our partial sum, right, the sum of the first 25 terms. We can plug directly into that formula, and we find that the sum of the first 25 terms is 1,175. So you're going to go ahead and finish these notes with an additional video based on our calculator, but for now, we'll call it here.